Well, my name is Javier Arias. Uh, all my expertise is in Latin America. I work from Mexico to Argentina in many countries. Uh, I have been working in the industry or with industry since 2012 when I started in Accenture. Accenture is a big four and was the first time in which I get in touch with big data and advanced analytics. On 2012, I see big data as and analytics as a technology with a huge potential. And what I discovered is that over the years, I found many functions and applications of this technology. I'm currently working in the wind power industry. As you see, I work in Latin America. I work with wind power, wind turbines, wind farm construction, and I install 11 factories in Latin America of these big components. A wind turbine is a high value asset. As you see, this is a picture of one of the plants. What I have behind me is the nacelle. It's like the heart of a wind turbine. And was a really big challenge because one thing is to install a factory in the US, in Germany, in Spain. Another is to do it in a remote area in Peru, in Colombia, in Mexico, or in Argentina. You have sometimes some limitations. And also, you need to deal with some challenges that make difficult the initial implementation of a factory. This is one of our plants. This was when the former president of Argentina inaugurated the nacelles plant. Some pictures about these main components. As you see, this is a wind turbine. The dimensions of these main components in tones and in dimensions of extension are really complex. See that, for example, a blade could have 72 meters to 80 meters, only one blade. So you need like complex logistics, you need cranes, you need huge trucks. And this is, in countries really problematic because if you have a convoy of 4 of these blades, and if you are driving, like in Germany, people drive, imagine passing a convoy of 4 trucks. You need to really have a really good traceability of what is happening in your real operations from the plant to the installation of each component in the wind turbine. So as you see, our global sourcing in Nordex Acciona, we have plants in China, in Vietnam, in India, in Mexico, in Argentina, in Chile, and in Brazil. So as you see, I'm a lawyer. I'm specialized also in HSE as an HSE professional. Over the years, I work a lot with installing plants, making the contracts, and working in construction and in engineering. I work a lot with quality and safety that are two of the main concerns that we have in a plant and also in a construction site. And I want to talk about how the industrial Internet of Things and big data contribute for the improvement of a manufacturing process and the product quality. But I'm sharing my experience and how I make this transition because I work with engineers. I'm not an engineer, but when you are working as a team, you are involved in topics that, for me, are really important to the moment in which I need to close a deal or to negotiate with our suppliers or contractors. So this is main characteristics of big data, because as you see, effective quality management depends on how much visibility you have of your process or your product. In other words, how you monitor and control your manufacturing process, the production assets, and the product outputs. It's really important how the wind turbine operates during the operation phase, but also it's important what happens beside the plant. In other words, and to make a nice conclusion of this introduction is, it happens, it matters what it happens inside the plant during the manufacturing process, but also it's really important the product outputs, how is operating this machine in the wind farm under different conditions, operational conditions or environment conditions. Well, this is the data value cycle. And after installing many factories in Latin America, I identified at the end of the day that we had gigabytes of data from multiple sources, like the production line, the production unit, the workflow of our employees. So this data, it's large volume of data, structured, semi-structured, unstructured, and the data by itself has no value. So in the wind power industry, we're using a lot of big data analytics to increase the efficiency of our operations, but also for the decision making. So this is the data value cycle, and I experiment this because in the factory we have thousands of sensors, and these thousands of sensors, I saw like data when it's processed by the advanced analytics, we can gain insights. We can convert data in value. We can convert that in knowledge. So, as you see, how I find value in data. Well, in the life cycle, it's not only datafication and data collection that makes the big data. It's also how you store, how you process, and how you analyze that. And me as a lawyer, what I saw was like data in dashboards. The dashboards for me were really clear to see what was happening in the plant. So when I work with the engineers, I saw, like, for example, some incidents that we could detect with a predictive or proactive approach, and that was really important for me. You know, like an incident in a factory, if stop the production line, we have a problem. Time is money. We need to maintain the workflow. We need to maintain our production line ongoing. So this is how I saw many sensors. I don't know about all of them, but engineers, I think that when we work together, I saw like a really nice and interesting process. It's how data goes from physical to digital and to digital to physical. So we have real operations, production assets, machines, we have people involved, and all this data goes to the digital record. So, for example, in a cell, if we have some missing parts in this main component, I could detect that from the moment in which the production line don't install a part or a piece of that main component. Sometimes happen that with COVID-19, we have many problems because suppliers were not delivering goods on time. So you don't have all the parts that you need to make the main component, but you cannot stop the production line. You continue, and the big data analytics will create some insights. For example, if you know which are your missing parts, we have some automated actions associated to this aspect. So if you don't have a part because the supplier don't deliver on time, the automatic action is to order that part, to let the part arrive at the construction site at the same time that the component is arriving, so you can be ready to install that main component in the wind turbine. So as I say, this double flow in which data goes from physical to digital and to digital to physical, we know is that we have insights, we gain insights, we transform data in knowledge, and that knowledge is very important for decision making to turn into actions. If you have a missing part, you go to the market and you buy it. So in the industry 4.0, I think that big data analytics in the wind power industry is one of the technologies that we are using, but I think that the digital twins is the next step. And this is really important for me because the wind power is also making a transition to hydrogen. You know, hydrogen is the new source, the new renewable energy, and the companies want to be more efficient, to reduce cost, and to provide high-value assets with better service profitability. So, as I said, my experience, how quality of a product or quality of a manufacturing process could be improved. Well, you need to combine manufacturing process data with the product outputs, and the data that generates the wind turbine during the operation. You need to combine what you have in the manufacturing process with the post-manufacturing. So I see that data is really important, but advanced analytics is much more, because data by itself has no value, and everything depends on how you are using data, how you are linking data with other data sets. So I think that in the wind power industry, from my experience, I see how we are in a phase of technology integration mixed with data management and advanced analytics. And what I saw really important in digital twins and big data analytics is that simulation and to have a predictive or proactive approach to identify defects in an early stage are dominating the new trends of industry. So from big data analytics, I found these 6 functions or applications that I'm using in the business, but also that has a big value to improve the manufacturing process in a plant, in a production line, or also in the operations of each wind turbine. We know how a wind turbine is operating in real time. We know everything what happens with a real wind turbine. The other day, for example, one of the wind turbines was impacted by lighting. And we can detect not only that, is how you can plan if you need to do a manual intervention, or, for example, you can make other kind of interventions like an update, a software update, or provide any additional feature to maintain this wind turbine operating in safe conditions. But well, these 6 functions or applications like analytics with artificial intelligence and machine learning, for me, was one of the big learning lessons that I had. The simulation, how we virtually test a manufacturing process, and it was really interesting to see how they combine data, a digital twin, for example, of a manufacturing process with a digital twin of a product. And from running a simulation, right, virtually testing new and different kind of productions procedures or processes, they can define behavioral changes to improve quality. So I think that predict production, predict quality, predict performance, as you know, prediction is one, for me, of the biggest values of big data analytics. Yeah, 3 minutes. So in digital twin, basically what I know from my experience is a digital twin of asset and processes. As I said, I know that everything what happened to the real asset will be reflected in the digital model. And this is really interesting because when you combine models, when you combine the digital twin of a product with a digital twin of a process, you can simulate and you can create many scenarios that can traduce in big value for the daily operations of the plant. And to conclude, I think that one, as I said, of the biggest values of the digital twins, when you connect digital twins, all the insights and all the knowledge that you can create to improve an asset operation. This is a digital twin of a single asset, but what happens if we include more digital twins and these digital twins could work simultaneously communicating one with each other? The case of, I don't know, a locomotive, you have a locomotive that digital twin that communicate with a signal and both can define an automated action. What happens if you have a network of connected digital twins like a transport system? Well, you can make it complex, but I think that the big value is in combining digital twins and in combining data outputs from a manufacturing process or from a product like a wind turbine. And this is more complex. You have an ecosystem of connected digital twins in which I think that is in the future a possibility, but my expectations for the wind power industry is to have digital twins to improve not only the quality of our wind turbines, also the safety of how we are operating. But well, I think that I try to resume what I'm living here in every project. We have many projects around the world. It's complex to understand the product life cycle management of every of these components. And I think that the full traceability from the factory to the end of the life cycle gives you valuable data that you need not only to improve quality, also to make safer operations at the plant, at the construction site. But well, this is my experience, and I wanted to share with you. And well.